The Principle of Relativity. When Albert Einstein was a 16-year-old teenager, he asked himself,
What happens if we chase after a beam of light at light speed?
intuitive reasoning, rooted in Newton's laws of motion, tells us that we will catch up with the light waves and so they will appear stationary. Light will stand still. But according to Maxwell's theory and all reliable observations, there is simply no such thing as stationary light. No one has ever held a stationary clump of light in the palm of their hand, hence the problem. This was the paradox that troubled Einstein for a decade. Luckily, Einstein was unaware that many of the world's leading physicists were struggling with this question, and pondered the paradox of Maxwell and Newton largely in the pristine privacy of his own thoughts. Einstein resolved the conflict through his special theory of relativity, and in doing so forever changed our conceptions of space and time. There are two simple yet deeply rooted structures that form the foundation of special relativity. One concerns properties of light, the other is more abstract. It is concerned not only with any specific physical law but rather with all physical laws, and is known as the Principle of Relativity. The Principle of Relativity rests on a simple fact. Whenever we discuss speed or velocity, we must specify precisely who or what is doing the measuring.
Let's consider the following situation. Imagine that George, who is wearing a spacesuit with a small, red, flashing light, is floating in the absolute darkness of completely empty space, far away from any planets, stars, or galaxy. From George's perspective, he is completely stationary, engulfed in the uniform, still blackness of the cosmos. Off in the distance, George catches a sight of a tiny green flashing light that appears to be coming closer and closer. Finally, it gets close enough for George to see that the light is attached to the spacesuit of other space dweller, Gracie, who is slowly floating by. She waves as she passes, as does George, and she recedes into the distance.
This story can be told with equal validity from Gracie's perspective.
It begins in the same manner with Gracie completely alone in the immense still darkness of outer space. Off in the distance, Gracie sees a red flashing light which appears to be coming closer and closer. Finally, it gets close enough for Gracie to see that it is attached to the spacesuit of another being, George, who is slowly floating by. He waves as he passes, as does Gracie, and he recedes into the distance.
The two stories describe one and the same situation from two distinct but equally valid points of view. Each observer feels stationary and perceives the other as moving. Each perspective is understandable and justifiable. As there is symmetry between the two space dwellers, there is, on quite fundamental grounds, no way of saying,
one perspective is right and the other is wrong.
Each perspective has an equal claim on truth. This example captures the meaning of the principle of relativity. The concept of motion is relative. We can speak about the motion of an object, but only relative to or by comparison with another. Thus, there is no meaning to the statement,
George is traveling at 10 miles per hour,
as we have not specified any other object of comparison. There is meaning to the statement,
George is traveling at 10 miles per hour past Gracie,
as we have now specified Gracie as the benchmark. As our example shows, this last statement is completely equivalent to
Gracie is traveling at 10 miles per hour past George.
In other words, there is no absolute notion of motion.
Motion is relative.
However, only constant velocity or force-free motion is relative. Not so for non-constant velocity motion or accelerated motion. This is because if a force was applied to George, he would definitely know that he is moving, even if his eyes were closed, and therefore can make no comparisons with other objects. The feeling is intrinsic. Even without such comparisons, he would no longer claim that he is stationary while the rest of the world was moving by him. Einstein realized that the principle of relativity makes an even grander claim. The laws of physics,
whatever they may be, must be absolutely identical for all observers undergoing constant velocity motion.